All right, today we're going to talk about solving word problems, and we're going to use your calculator to solve these. So this is a typical question. The path of a high diver is given by the equation y equals minus 4/9 x squared plus 24 over 9x plus 10, where y is the height in feet above the water and x is the horizontal distance from the end of the diving board in feet. And some typical questions that might be asked is, what is the maximum height of the diver? How far out from the end of the diving board is the diver when he hits the water? And how high is the diving board? So when you have these kinds of problems, what you really want to think about is, what is each question asking you in terms of some of the important values of your parabola, for instance, the vertex and the intercepts. So A says, what is the maximum height of the diver? Well, if they want the maximum height, height is your y value, and if they want the maximum, it would have to be the vertex. So A is asking you really for the y value of the vertex. How far out from the end of the diving board is the diver when he hits the water? Well, if he's hitting the water, then that's going to be your x-intercept. And part C says, how high is the diving board? Well, that's his starting point, so that would be your y-intercept. So this is kind of what the picture would look like. You've got a diving board and he's jumping off and going into the water. So let's go ahead and put this information into our calculator and see if we can't figure out these. So I've already put this equation into my calculator, and you can see I put the fractions in parentheses. Some calculators have a nice little fraction button, but mine's an older one. It does not. So if yours is older, make sure you put that in parentheses. I've set my window. I set x min to negative 110 and y min to negative 115. If this is a word problem, you want to keep x minimum basically 0 and y minimum basically 0, because negatives don't really have any value in a real world problem. But I needed a little bit of space in order to see the graph, so I set it equal to negative 1 instead of 0. So if I hit graph, you can kind of see that this is what it looks like. So let's go ahead and find the vertex. So second trace, the vertex is going to be a maximum. So I'm going to put my cursor on the left bound. Over there looks good. Hit enter. And then the right bound. Over there looks good. Hit enter. And guess, so I'm going to hit enter again. And it looks like my vertex is at 314. So it asked me for the y value of the vertex, so it would be 14 feet would be his highest point. Then it asked me when did he hit the water, so he would be hitting the water down here at this point. So that's my x-intercept. So I'm going to go here and go to 0. And I'm going to go left bound all the way down here. I'll hit enter. And I've got to go negative, make sure my y's are negative. There they are, and hit enter again, and guess, and hit enter again. And it tells me that my x-intercept is at 8.6. So he's going to be 8.6 feet away from the end of the diving board. And how high is the diving board? Well, we can take a look at the equation, and we know that just by looking at the equation in standard form. But we can also find it saying second trace, and then going 1 for value and hitting x equals 0 and hitting enter, and you see that it would be at 10 feet, which makes sense because you can see the equation right up here, and you can see this c value is 10, and that matches that 10 feet. All right, let's take a look at another example. The number of bacteria in a refrigerated food is given by the function nt is 20t squared minus 20t plus 120, for negative 2 t is between negative 2 and 14, where T is the temperature of the food in Celsius. So now they've given you a restricted domain, so you can use that to help you graph this, because you know T has to be between those two values. And they're asking at what temperature will the number of bacteria be at a minimum? All right, well, once again, let's go ahead and graph this and see what it looks like. Now I'm going to clear this equation, and 20x squared minus 20x plus 120, and I'm going to set this window negative 2 to 5, and my y's I'll set negative 10 to 250. You can use your y value of your equation, your y-intercept in your equation to kind of help you figure out what your y max would be. You know it has to be higher than that c value of your equation. So I hit graph. You can see this is what the equation looks like. They asked for the vertex, so second trace. The vertex now is going to be a minimum. I'm going to put it on left bound. A little more. Enter. Right bound. Enter, and guess, hit enter again. And I see that my vertex is at 0.5 and 115. The question asked me for at what temperature will the number of bacteria be minimal? So my temperature is actually on my x-axis. So my answer would be 0.5 degrees Celsius. All right, there's an equation that you need to know, and it's called the thrown or dropped equation. So when an object is thrown, it is always given by this equation, where ht is the final height or the ending height. T will always be your time in seconds. V is your initial velocity in units of feet per second, and HO is the initial height or the starting height in feet. So this object is always in feet. This equation is always in feet per second. That negative 16 is a gravity factor, obviously, when things are going to be pulled back down to Earth. So that negative 16 is in feet per second. If an object is dropped, then there's no initial velocity, so this term here would go away, and your equation would just be negative 16t squared plus HO. So let's take a look at an example using this. Jason jumped off a 480-foot cliff in the ocean in Acapulco while vacationing with some friends. His initial velocity was 16 feet per second. And they asked some typical questions. So the first thing you want to do is write the equation. Well, they give you the two pieces of information you need to know. You need to know your initial velocity, and you need to know your initial height. So if you put those two pieces of information into the equation, you get ht, your ending height or your height at any time, is negative 16t squared plus the initial velocity, which was given as 16t, plus your initial height, which was 480. Now that you have that equation, you can put that in your calculator and you can answer any question. How long did it take for Jason to reach his maximum height? Well, here they're asking you for the x value of the vertex because they're asking you how long. So that would be in seconds. What was the highest point that Jason reached? Again, they're talking about the highest point, so they're talking about the vertex, but now they're asking you for the y value of the vertex. And Jason hit the water after how many seconds? So now they're asking you for the x-intercept. And that's pretty much it. If you have any questions, let me know.